All right, here are the basics of performing a t-test in statistics. Let's take a look at this question. You can pause the video to reread it if you'd like, but just highlighting the key points here in the paragraph. It says the average amount of allowance that a child gets in America is $5. So we got a $5 claim, and it's saying in all of America, so it must be our population's average. We think that this sounds too low. We collect a sample of 100 children in Amherst and Tonawanda, so we've got a total of 100 children, that's our N, and we get their average is $5.40. So that's not coming from the population, it's coming from just our sample, so it is our sample average. And also, the sample has a standard deviation of $2. Since that standard deviation is coming from the sample, it is not the sigma. It is actually the standard deviation from the sample, which is abbreviated SX. So we're going to take those pieces and use those pieces to construct the hypothesis test. It can be done in different ways. I like to use a four-step process. The very first step is to set up your null hypothesis and alternative hypothesis. The claim is that the true average was $5, and we said in the reading, it said that we think that this sounds too low, which means we actually think that the true average should be higher than $5. You have to pay close attention to the reading and not be suckered into seeing words like too low and think about putting a less than. You know, we think that this actually sounds too low, so we think it's actually going to be higher. If the question was reworded, it could say, we think that it's actually much higher, then it becomes still also greater than. So just because you see a word that says low or high, don't feel like that means automatically it's going to go in one direction or the other. So here's an example where it says we think it's too low, and you think low might mean less than. Well, no, we think that this is too low. We think that the actual one must be higher. So that would be my first step. In my second step, I'd like to check the conditions. Is it a simple random sample of children? And it is. And do we have enough children in the sample? Is 100 big enough? Well, as long as it's 30 or higher, we're in pretty good shape. So both conditions actually are passed, and we can go on and complete the second step. Besides writing down the conditions, I like to name which test I'm going to use. This is a t-test because the standard deviation is coming from the sample. And then the last thing for my second step is to set the significance level, or just restate it. It says we're using 1% significance. So a significance level is how low is too low when it comes to probability. Anything lower than 1%, and we're going to say that our sample was so rare that we're going to reject the idea of the Ho and believe that this is actually true. In other words, if the probability is lower than 1%, then it pretty much destroys our belief in this. Third step is going to be to do some calculations. Now, this can be done in a few ways. Let me show you, working it out by hand, what you would have to do. You'd have to actually figure out the t-score, or the t-value, which is found by using this formula here. You'd have to insert all the pieces that were given into this formula. So we're told that it's $5 and our sample is $5.40. We're told that it's $5. The standard deviation was 2 coming from the sample, and we're talking about 100 children. You're doing all this work here to actually dig up your t-score, which ends up being perfectly 2. Well, that was just a wild coincidence. All right, so the t-score is 2. That's the second most important number from our work. We have to still figure out the probability, but you can get an idea that the probability is probably going to be on the low side because our t-score is farther away from 0. The closer it is to 0, the more probability you get. Just like doing a z-test, we have to visualize the probability by creating a model using a curve. And in this case, since we're using a t-test, we're actually using a close cousin of the normal curve called the t-curve. And the t-curves are very similar to normal curves. They look, almost exactly the same as a normal curve, but a normal curve would have actually a more higher peak to it. So a normal curve would actually be a little bit thicker in the tails, or I'm sorry, be a little more thinner in the tails, and actually peak up a little bit higher. And there are many different t curves. It all depends on what degree of freedom you are using. And if you think back to when we did our work with t intervals, the degree of freedom formula is n-1. So in this particular case, since we have 100 children, our degree of freedom would be 99. So this would be a t curve with degree of freedom 99, and you should write that down just to emphasize what type of curve it is. All we have to do is now place our t-score on the curve and decide which direction to shade in. If you remember, it's greater than in the alternative, so it means we're going to be shading to the right. And we're going to want to collect all that probability. So that's a lot of work there in that third step to get all those calculations done. We still have to figure out what the probability is. If it was a normal curve, we could use the normal CDF command on the calculator. But since it's a t-curve, we're going to be using tCDF, which needs 3 numbers. The first number is the lower end of the range, so we're starting at 2. Second number is the right-hand side of our range. So we want everything that's bigger than 2. So let's say 2 to 1,000 would be enough probability to the right. And then the last number is the degree of freedom. So this calculation done on the iPad or graphing calculator will give you the probability of getting a sample that is this far off the mark. So how rare would it be to get 100 children, how rare would it be for 100 children to give us an average of 540 or more when the average is supposed to be 5? So we're off by 40 cents. Is that big of a deal? Well, we're finding out through this calculation that there's a 2% chance of getting a sample that's that rare. Now, is that a low probability or a high probability? Well, you just compare it to the significance level to make a decision. And that brings us to our fourth step. The last step is to make a conclusion. So those are the first 3 steps, and then the last part would be just to name the conclusion. And because the p-value is greater than the significance level, it means that we've got enough evidence here to reject the ha and be in favor of the null hypothesis, being in favor of the ho. So because the probability was low, but not too low, it's actually more than 1%. So even though our probability is low, 2% chance, over in the beginning we've actually said that a 1% chance is what we're going to consider to be a low probability. So even though it's a low number, it's still higher than our significance level. So it's low, but not that low. So since our p-value is greater than the 1%, we're going to be in favor of the idea that the ho is actually correct. So it's off by 40 cents, and we're figuring out that that's probably not that big of a deal. All right, to make things a little bit easier for us on that third step, you could actually use the graphing calculator to generate all that work done right there. And I have to push this aside. So you could actually type in to your graphing calculator after you press Stat and slide to the Test menu. You could find t-test and enter in all the data just like I did there, and then select Draw, and you'll end up getting the t-curve drawn for you on the graphing calculator, along with the t-score and the p-value. So as long as you're writing down on the AP exam, or the exam I'm going to give, as long as you're writing down all 4 steps, on the third step you could actually take some major shortcuts and actually let the calculator do the work for you, or work it out by hand. This is the interface if you're using the graphing calculator app on our iPads. This is the type of interface you'd actually see for that third step. Again, it does have the same pieces as the handheld calculator. Just make sure that you press Enter as you are entering each of those numbers into the calculator. And you can see it gives you your p-value there and your t-score. And then in this area here, you decide what type of alternative hypothesis you're dealing with. In the very beginning, we said that it was a greater than, so we're going to select that one. Making sure you hit Enter in between is an important thing for this to actually show up. And you can see here it's giving you the p-value drawn right there for you as well. All right, hopefully this was helpful in putting everything together for you.